Hello and welcome to my video series on top LeetCode questions. In this video series, we will be covering the most popular and frequently asked questions from the LeetCode. So these questions are commonly asked in software engineering interviews. So if you are preparing for your upcoming interview, so this video series is definitely going to help you out. In this video series, I will not be focusing on the code, rather I will be focusing on the concepts. So this will enhance your problem solving skills. Writing code is easy when you know how to solve the problem. So whether you are a beginner or an experienced developer, this video series will provide valuable insight and tips on how to tackle these problems. So by the end of this video, you will have the solid understanding and most important concepts and techniques you need to know to ace your next interview. So let's get started and conquer the top LeetCode questions.
So the first problem is two-sum problem. So what we have given here is an array nums and a target number 9. So what we want to find is the indices of two numbers such that they add up to the target. Okay, so we need to find two numbers such that they add up to the target, right? So what we need to do is one brute force way of doing it, right? So brute force way of doing it is you can compare each number with every other number, and if during that process if you find a pair which adds up to the target, then that's your answer, right? So you can just do it in n square, right? So you can have a for loop inside a for loop, and let's call this pointer I, and this pointer will be starting from I plus 1 and till the n, right? And you can compare if the target minus nums of j equals to nums of I. So it's just the same way of doing it. So if that is true, means you find your answer and you can return I and j. So that's a brute force way of doing it, that you can compare each number with every other number and you can return it in the answer. So let's say what we want to do is 9 minus 2 equals to 7. So if we have number 7 in the right part of the array, so that's going to lead us to the answer. So if we take a look of any other number, let's call it so the array is 2, 7, 11 and 15, right? So let's talk about 11. So 9 minus 11 will be minus 2. So if there is any element present in this part of the array which is minus 2, then we know that that's going to lead us to the answer. So if you upfront know whether the number is present in this array or not, so that can help us. So what we can do here is we can use a hash map kind of way. So in hash map, what we can store is two numbers, or the number and the index. So in the first for loop, what we can do is we can start with the I till the end, and if we find the number what we will find in the map, we'll find this number target minus nums of I. So if we find this number in the hash map, right, so means we already encounter, so we got our first match and we found our answer. So let's take an example here. So 2, 7, 11 and 15. So when you came at 2, there is nothing in this hash map, right? So what you will do, you will find target minus 2 will be 7 is not present. So what you will do, you will store the 2 here. So 2 index is 0. Then you came out to the 7. 9 minus 7 equals to 2. So you will find if there is 2 present in this map or not. So we already have 2 here, so that will be our answer. So so our answer will be 0, 1, and it's a jth index, and this is what you can got. So the next question is, we need to find first position and the last position of the element in the sorted array. So we have given an array and we need to find this number, and we need to return the first index and the last index of that element in the array. So as you have already guessed that it's a sorted array and we need to find something, so we definitely going to use binary search. So that's always true. So here 5, 7, 7, 8, 8 and 10. So the way binary work, as you already know, the binary search works with the you will always find the mid and try to divide the whole array as in the part of 2. So you will compare you whether you want to go on the left or you want to go to the right. You are already familiar with the binary search. So what modification what we'll do with the binary search is that, so if you let's say you have this element as the mid, okay, to how do you know that this is the first element first occurrence of that element? So what we can do is, we can, since this is sorted, so if this the previous element, either this is the zeroth element or the last element to that, means let's call it a of mid minus 1. If it is smaller to a of mid, right, if that condition is true, that is your first occurrence. And if the right side part of it is bigger, if a of mid, either it is the last element, that will be n minus 1th element, or a minus 1, a mid plus 1 is greater than a of mid. In that case, that is your last element. So in those two cases, so you will be getting your answer. So we basically we will write two different variations of binary search, one to find the first occurrence and another one is to find the last occurrence. Since both of them going to be in log n plus log n will be log n, right? So 2 log n, so that will be a log n. So still it's a optimized approach. So the next question is remove duplicates from sorted array. So we have given a sorted array in non-decreasing order and we need to remove the duplicates in place. Okay, so if we remove the duplicates, then the first k unique elements will be in the front and the duplicate element will be at the end, or you can just keep whatever you want. So since we cannot, so we are also not allowed to use extra memory. So basically here you can't use extra memory, means you cannot use hash map or like hash chat to store the values. So we have to use a kind of pointer approach here, right? So so let's see how we can approach this problem. So here if you see, let's take this example. So in this array, you in this array if you see, there are duplicates, right? So the first element will always be there, so we can start with this element. So this is always unique, so it has to be there. So let's talk about two pointers. One is index pointer and one is the traversal pointer. So the index pointer is at here, and we will see if this element is duplicate or not. If this is not duplicate, then we'll insert at ith index. And the traversal pointer, or we can call it p pointer will move toward right, and it will, whenever it find a unique element, it will unique element for the first time, we will insert at the index I. Yeah, so this is a small code here. So if you see, the first pointer is p is pointing to the first element, and so the ith element is actually the moving toward the right. So in this for loop, we are checking whether the ith element is equal to the I minus 1th element or not. If it is not, means it's a unique element and came for the first time. So what you will do is, you will insert at the pth index and you will increment the p. So at the end of the at for loop, you will encounter that all the unique elements are in the first part of the array and the p is pointing to the size of the array, and you can return the p, and that will be your answer.